Hey, in this video, we are going to talk about, as you can see, kinetic molecular theory. So we're going to start talking now about heat and temperature. So kinetic molecular theory, what this is talking about first is that matter is made up of atoms that are constantly moving. So what are atoms? We need to just do a little bit of review on some terms because I'm sure it's been a while since you've seen some of these. So atoms are the smallest functional unit of matter. So you can divide atoms into smaller pieces. You might be familiar with terms like protons and neutrons and electrons, but those pieces make up atoms. So if you break an atom into those smaller parts, it doesn't function any longer. So you need all of those pieces together to get something that actually works together. So if you get a group of the same type of atom together, you might be familiar with the term for that. Those are called elements. So I've got a couple of elements here. So elements are made of the same atom. So gold, here this bar is made out of, almost all gold. But pretty much every atom in that bar is going to be gold. Over here, we've got two different samples of carbon, coal and diamond. They are actually both made out of carbon atoms, just arranged in different structures. So think of some other other elements that you might know. So things like oxygen, nitrogen, and so on. A couple of other terms that I'm going to be using, not just in this lecture, but in future lectures. So I figured to go ahead and talk about them now. So compounds are any material that is composed of atoms of two or more elements. And they're not going to easily be broken apart. So who are we talking about here? Things like water, carbon dioxide, carbon monoxide, sugar. Trying to think of any of the other ones off the top of my head. Of course, now my mind went completely blank. So a lot of the things actually that you know in the world are actually compounds. There are a few that are common. Things like salt are not considered compounds. Think about it. If you put that in water, it does dissolve pretty easily. Sugar does too, but when you try and take the actual atoms of sugar apart, it's very difficult to do. One of the only ways you can do that is actually to ignite it with a flame. So that's what compounds are. Molecules, on the other hand, this is the smallest particle of a compound or a gas element that can exist and have the characteristic properties of the substance. So pretty much everything actually can be a molecule. All compounds are molecules. So you can have a water molecule, a molecule of carbon dioxide, a molecule of nitrogen oxide. Then you can have, like I said, gaseous elements. So nitrogen, oxygen, hydrogen. Those guys are going to be what we call diatomic, meaning that they have to come in pairs to be stable, but they are molecules. So an oxygen molecule is two oxygen atoms that are bound together. And then there is a group of gases that are monatomic, meaning that they can be a single atom by themselves. They're the only elements that can do this. And those are the noble gases, things like helium, neon, argon, radon. So they are over by themselves. If you know the periodic table, they are the guys on the far right-hand side that we do call the noble gases. Okay, so we can now get into some things more directly related to heat. We need to talk briefly about phases of matter. This is probably a review for many of you, but just real briefly, there are three common phases of matter on Earth. So what are they? Well, the first one will be solids, and the letters that are here match up with the pictures that are over on the right-hand side. So the A picture here is a picture of what a solid looks like at the atomic level. So if we could zoom in and look at its atoms, this is what they would look like. Solids are any material that have a definite shape and volume. So think of a lot of the objects that we work with every day, tables and so forth, your computer. These guys don't change their shape and volume unless you do things like, pound on them. And this is because the molecules are fixed. So if you look at these guys, they have bonds between them, but bonds don't move. There's no space in between them. They do vibrate, so that's why they have these little kind of like antenna almost in the picture around them. That's to show that they're shaking, but the molecules can't move. They're locked in place, but they can shake, they can vibrate. And the spacing of them dictates the density. So you probably know that things float like in water. That means that if it floats, it's less dense. So that means that the atoms are spaced farther apart, but if it's a solid, that means that they're fixed farther apart. The next phase is a liquid, and liquids are pictured like these guys over here, B. These guys do have bonds between them, but they have a variable shape and then a fixed volume. So fixed volume because they're still bound together. So they still have to stay packed, but they have a variable shape because they do have space in between them. So they can move around. And as you can see, they can spin and so forth. And so they can rotate and vibrate. And this is what allows things like water and so forth to take the shape of containers, because these molecules can slip and slide past each other and rearrange themselves inside of those containers. Our last common phase on the planet is the gas, which is letter C down here, and it has no fixed shape or volume. Think about like a balloon. When you blow up a balloon, yeah, the balloon is the solid material, but the gas inside of it is not fixed, right? You can squish it to make new shapes, and the other thing is the volume can change. So if you heat it up, it can expand. If you cool it down, like you put it in a freezer, it can shrink. And the reason why it has these properties is because the molecules are really far apart. You can see there's no bonds between them like you have up here. And they move around randomly and run into each other. And when they run into each other, they bounce apart and go away from each other. So that is our 3 phases of matter. This actually makes a big difference when we're doing things like heating things. There is one last phase of matter I just want to point out because some of you may have run into this, and that's plasmas. They are gases that are made out of positive ions. So these are atoms that have lost some of their electrons and then just free electrons. These guys are cool in the fact that they are gases that can conduct electricity because they have these ions and electrons, and they also can interact with magnetic fields. The most common place that we have plasmas is actually not on planet Earth, but in our sun. But we do have some sources of plasma here on the planet. You can see plasmas in fluorescent lights and in neon lights. Otherwise, to see a lot of them, you're going to have to go out and look at the stars. There are actually 2 now out on the market, plasma lighters. These are those lighters that don't blow out, and it's because they have a little plasma arc in them. So they make just a very small amount of plasma, but that's very hot. All right, speaking of hot, let's talk about temperature. So what is temperature? So temperature is the measure of the average kinetic energy of the molecules making up a substance. So in the last section that you watched, you learned about kinetic energy, the energy of movement, of motion. Well, in this case, it is the average, we're looking at the average energy of the molecules moving around in the substance. So whether it's a solid, a liquid, a gas, it doesn't matter. We're looking at that average kinetic energy. So if it's a solid, we're looking at the average amount of jiggling vibrations that we are seeing in that solid material. So it doesn't matter if we're jiggling, vibrating, rotating, or like in a gas, actually physically moving. All of that's kinetic energy that we can measure. So as the temperature rises, think about what happens to the kinetic energy of those molecules, okay? So if you've got, for example, something like my jug of water here, right now my jug of water is kind of cold. But if I start putting my hands around it and warming it up, what's happening to the molecules of water inside of it? Sorry. And what's happening is as you add energy, as you warm up the object, as the temperature rises, the average kinetic energy of those molecules goes up. And so you can see down here, this is the speed of the molecules, and you've got increasing numbers. It's not, they're not giving us an actual number, but this is what we're looking at when we measure temperature. We're going to take the average speed of these guys, the average kinetic energy, and take that as the measurement of temperature. So as the temperature goes up in a material, like my water bottle, this hump right here is going to shift because more and more of those molecules are going to start jiggling and vibrating and rotating as there's more energy available for them to do that. All right, so the kinetic molecular theory, again, it's just talking about the fact that these atoms are jiggling and rotating and moving around in the material that they're in. So matter is made up of these atoms that are constantly moving, and by increasing the temperature, aka adding energy, what about the atoms increases? So as you increase the temperature, the kinetic energy of those atoms is going to increase. They're going to jiggle, vibrate, rotate more because there's more energy available. Think about it like small children. So at nap time, they're kind of sleepy and tired, but then as they wake up, they start to get more energy, and then if you tell them that they're going to go to recess, they get more energy, so they will get more excited. And so that's the idea, that you're adding energy so they have more kinetic energy. So that would be the idea of raising the temperature. So the average kinetic energy goes up. What this can do is it can change the phase, so it can move a material from a solid to a liquid, or from a liquid to a gas, or it can expand or contract the material. So depending on the properties of the material, adding that energy, increasing the average kinetic energy, can make that material expand because the molecules are moving around more, and so they need more space. All right, I'm going to stop here and pick up the next lecture with thermometers.